In this lesson, we'll be looking at limiting reactants, and for the O levels, we will limit ourselves to discussion on irreversible reactions. For irreversible reactions that have two or more reactants, the reaction will stop when one of the reactants is used up. That reactant will be known as the limiting reactant. The other reactants that are left over are considered in excess. So how will you know if a question requires you to use concepts of limiting reactants? Usually when information of the amount of more than one reactant is provided. How will you identify the limiting reactants then? You are required to compare the moles of reactants to the balance equation. In cases where volumes of gases are provided, you can compare volumes directly also. Right? Because volumes of gases is proportional to the moles of gas. It's very important, do not compare masses of reactants. If you are given grams, kilograms as information, convert them to moles first. Why is finding out limiting reactant important? When the limiting reactant is used up, the reaction will stop. That will mean that it controls the amount of products formed. Also, it will mean that limiting reactants control the duration of reaction. We start off with a simple example. Hydrogen reacting with oxygen. If you are not given the balance equation, you have to write it out on your own. 2 moles of hydrogen is expected. It will need 1 mole of oxygen for reaction. So this statement is from the previous slide. How will you know that the question requires you to use concepts of limiting reactants when we have information of more than one reactant? So for example, they tell us that we add 2 moles of hydrogen and 2 moles of oxygen together. Right? They give you information that tells us the amount of 2 reactants. This is a clue that limiting reactant concepts are required. So how do we find out which one is limiting? Which one is the one that will be used up first? As a habit for me, I will take the first piece of information as a basis and ignore the second piece for the time being. Alright, so 2 moles of hydrogen, I will write out the statement. 2 moles of hydrogen will need how many moles of oxygen based on the balance equation. So 2 moles of hydrogen will require 1 mole of oxygen. Now this statement, once it's ready, we will compare to how much oxygen do we actually add. We needed 1 mole to react with the 2 moles of hydrogen. We needed 1 mole, but we added 2 moles of oxygen. You should be able to see that we have added too much oxygen. So oxygen in this mixture is excess. In other words, hydrogen will be used up first. Hydrogen is our limiting reactant. So a quick recap. I will use the first piece of information. That's just my habit. You could use the second information if you want. I'll write the statement based on the first piece of information. Once I have the statement, I'll compare the amounts for the second reactant to see whether for the experiment is it too much or have I not added enough. Okay, we will see more examples just to make it clearer. Second example, we will use the same reaction, hydrogen and oxygen, but now our quantities have changed. Now I've mixed 4 moles of hydrogen and 1 mole of oxygen. So let's figure out which one is the limiting reactant. Okay, I'll use this first piece of information, 4 moles of hydrogen, and I ask myself, if I have 4 moles of hydrogen, how much oxygen do I need? Right, to look at how much we need, we look at the balance equation, 2:1. So for 4 moles of hydrogen, I will need 2 moles of oxygen. Right, then we compare. I needed 2 moles of oxygen, but I've only mixed 1 mole of oxygen to the mixture. I need 2 moles, I've added 1 mole, I've added insufficient oxygen. In other words, the oxygen will be used up first. Oxygen is the limiting reactant in this mixture. The hydrogen is in excess. Let's look at the third example. Same reaction again, different amounts mixed together. Here we have 1 mole of hydrogen mixed with 1 mole of oxygen. Alright, I think by now you know the drill. We'll write a statement based on the first piece of information. 1 mole of hydrogen will need half mole of oxygen. This is what is needed. I need half mole of oxygen. I've added 1 mole of oxygen. So in this mixture, we have too much oxygen added. Oxygen will be your excess. Your hydrogen will be the limiting reactant. Same reaction, but let's do it in terms of volume now. Hydrogen, we added 12 cubic centimeter. Oxygen, we added 10. Right? It doesn't really change the way we write our statements. I'll write it based on the first piece of info. 12 cubic centimeter of hydrogen will need 6 cubic centimeter of oxygen. Okay, because ratio is 2:1. I only need 6, but I've added 10 cubic centimeter of oxygen. So we can see that this 10 cubic centimeter is too much. Oxygen is excess. Hydrogen is limiting. Right, at this point, it's also important for you to realize that just because the quantity is more doesn't mean it will be in excess. Right? For example, you see you have 12 versus 10, but it's actually this 12 that is not enough, is limiting. So it's not just a simple comparison of the numbers. We have to take into account the ratio that they react with. It's not always the smallest number. One more example on this reaction. Here we have 6 cubic centimeter for both reactants. So we do this faster now. Statement: 6 cubic centimeter of hydrogen will need 3 oxygen. Right, we needed 3. We've added 6. So again, oxygen is too much in this mixture. Hydrogen is your excess.